this shiny interface, first you have to enter the creatinine clearance of the patient. Then you have to choose the administration route, oral or intravenous. If it is the patient at steady state, yes or no. The dose of valganciclovir or ganciclovir. The time infusion, especially if it is intravenous, generally it's 1 hour. The dose interval between two dosages, and then the time after dose for the computation of AUC. Optimal sampling times for oral administration are 1, 2, and 6 hours post-dose, and for IV administration it is 1, 2, and 3 hours post-dose. And then you have to put the concentration that are associated on each time after dose. Then you can click on compute the AUC 024 estimation, and AUC will be computed here. So it is the computation of AUC only based on 3 samples instead of 7 or 8 samples. Here you have also the historical data of all AUC that has been computed before. If you want to delete this historical file, you can click here, reset historical data. Here, with these 3 samples, 1.5, 5, and 1.5 mg per liter, we have an AUC of 41.8 mg per hour per liter. So here it is a PK part, but we have also a pharmacodynamic part. If the initial viral load, for example, is at 4.5 log 10 IU per milliliter, and the initial AUC is 40. You can compute this initial AUC with this first PK part. Then you have to put the duration between the initial and the second viral load in days, for example, 7 days. If this second viral load is at 3.5 and we have still 40 mg per hour per liter as AUC, we can plot the viral load dynamic here. And we can see that the patient will be negative at day 18. If, for example, we increase at 80 the AUC, we can change the configuration, and we can see here that the patient will be negative around day 16. We can also change everything. If you want, for example, duration between the initial viral load and the second viral load of 5 days, we can also plot this. It is quite fast. Here it is 15 days, the day of the negative value. We can also put other value if we want to add other points.